Hi everyone, welcome to the blockchain big picture video. Today I'll be taking you through two main use cases. One, the developer actually deploying a smart contract on an EVM compatible chain. And two, the user actually using this deployed smart contract and everything that goes on under the hood when these two processes happen. The goal of this video is just to give you a high level overview. Let's get started. So first we'll start with the blockchain itself. You see this on my screen. Here there are just three nodes, and these three nodes will do some sort of consensus to talk about kind of what transactions are coming in and what transactions should be included. And we'll get back to kind of the more interesting details of consensus later on in this video. Next we have this blockchain state, and it's important to note that this blockchain state is derived. The blockchain itself doesn't actually hold state, it just holds state transitions. And it's up to third parties to actually determine the state of the blockchain. So we'll start with state 0 here. Our user just has a wallet, just nothing state, it's a 0, but we'll get to state 1 and 2 in a bit. Great, now let's start with the first user journey. This is the developer who wants to deploy a smart contract on chain. We have the workflow here, but we'll go through each one of these steps in detail. So first, what the developer is going to do is write a smart contract. This smart contract will be in Solidity, and as a reminder, smart contracts are simply programs that just go on the blockchain. Next, what the developer is going to do is compile this smart contract Solidity that's in Solidity into bytecode, which is essentially a blockchain-friendly version of the smart contract. They're then going to create a transaction. It's called create contract transaction, and they're going to send this to their wallet to be signed. So here we're on step B. And every transaction needs to be signed when it goes on chain. And this is no different. So now that the developer has created this transaction that essentially declares that, hey, I want to create a smart contract, this wallet can now send this signed transaction to a node provider. And we'll use Alchemy. It's probably the most popular node provider. And a node provider is essentially an easy interface through which users and developers can interact with the blockchain as opposed to have to dealing with nodes themselves. And node providers are cool in that they oftentimes run their own nodes. So Alchemy themselves are running their own node, but that's fine, right? They abstract away the complexities of running a node on chain through a simple HTTP API. So now that we've sent this transaction to the node provider, Alchemy will do the work of actually submitting the transaction on chain. And here's where we get to consensus. These three nodes will essentially talk between themselves and be like, hey, is this transaction valid? Was it signed appropriately? Is there enough gas in the transaction to cover creating this transaction? And if all these checks pass, this transaction will be confirmed on chain. And what this means is now we'll have a new state on the blockchain, and we'll have this new smart contract account with the corresponding bytecode of the developer. Great. Now that the developers actually deployed a smart contract, they actually need a front end for users to interact with their smart contract. And this is called a dApp. And you can essentially think of dApps as a front end for a back end. And the back end in this case is a smart contract. But if you're familiar with how current apps are built, a back end could simply just be a web server. You can think of a smart contract as an analogous back end to kind of a Web 2 web server. Cool. So this will just look like a website. You can deploy it as you would normally using a service like Vercel, and you'll have a deployed app, a deployed dApp, and now you're at dApp.com. Cool. So now it's the developer user journey. Let's take a look at what the user has to do. So we come to the user here. Again, the whole thing is written out here. Feel free to pause the video, but we'll go through each one of these steps one by one. So now we have this user, and they end up at dApp.com. Maybe the developer convinced them to use it, they saw it on Twitter, something like that. So now that this user goes to dApp.com, in order to interact with the smart contract, say, for example, the developer wanted to create a game, and now this user wants to create a sub-game. Like say it was tic-tac-toe, and the user wants to play their friend. They're going to need to create a transaction. So what this dApp will do is actually use what's called a provider, not to be confused with node provider. And this is simply a JavaScript library that abstracts away some of the complexities of creating transactions on front ends, like on this dApp. So the deployed dApp will now talk to this provider, be like, hey, I want to create a transaction, the ethers.js, which is an example provider. We'll say, sure, here's a transaction. And now this transaction is almost ready to be submitted to the blockchain. As I mentioned earlier, all transactions need to be signed before they're submitted on chain. The blockchain needs to know who actually sent this transaction. So this dApp will actually send this unsigned transaction to the user wallet. And the user wallet, in turn, which is oftentimes a Chrome extension, will show a little pop-up to the user. Be like, hey, I got this transaction from this dApp. Should I be signing it? And the user will manually confirm yes or no. And if the user says yes, now the transaction is signed and is ready to be sent on-chain. Cool. So now this user wallet will send this transaction to the node provider. And you'll notice that this process is actually pretty similar to what the developer did when they sent the signed transaction from the developer wallet. The node provider will receive this transaction and forward it along to the blockchain. And same sort of deal here. The blockchain will do consensus and arrive at a conclusion. If the transaction is valid, it will be confirmed. And now we have a new state. Say this user wallet received an NFT for interacting with the game. That will now be stored at the user wallet. Again, this is a derived state. This would only be represented in a transaction, and it would be up to someone else, maybe something like Etherscan, to actually show that this NFT is actually landed in the user wallet. Great. So the final piece here is that there's a little bit of background work happening. When the node provider submits the transaction on chain, the dApp doesn't actually know when the transaction is confirmed. As I mentioned, the blockchain is doing a bit of background work to see, is the transaction valid? Should we confirm it? So the dApp will actually also be polling this node provider to figure out when this transaction is confirmed. Sometimes on some chains, this can take a few minutes, if not longer. And once this transaction confirms or doesn't, the dApp will know, okay, hey, you could tell the user, be like, hey, your transaction confirmed or it didn't confirm. And then that's the full story of a user actually taking an action on this dApp, right? They created a transaction, sent it on chain, and waited to see if it confirmed. Cool. So that's a high-level overview of this entire system. From a developer actually creating a smart contract on chain to a user actually going to the dApp that the developer created and using this smart contract to perform some action on the blockchain. That's all we have. Thanks so much for listening. And if you have any questions, feel free to reach out. Thanks.